In this video, we'll be discussing some of the practice problems for option C, energy, nuclear fusion, and fission. For the first problem, since the question is pretty long, so just pause the video if you guys want to read the question. And as it is having part A and B and C, I'll be breaking them into 3 parts and solving them one by one. So for part A, the question is asking, deduce the 3 nuclear equations for the reactions taking place to form plutonium-239 from uranium-238. And looking at the question, we can see that it has already stated out the 3 steps of this nuclear equation, in which first of all, the process involves reacting uranium-238 with a neutron to produce uranium-239. And I am writing that equation here, in which we are having uranium-238, and it is reacting with 1 neutron to produce uranium-239. And in the next step, we can say that the question says, which then undergoes beta decay to form neptunium-239. And in this steps, the product from the first equation is undergo beta decay to form neptunium-239 and produce beta particle. In the next step, the question say, which then further undergoes beta decay to give plutonium-239. And in this step, we can see that the product from step 2 is further undergoing a beta decay to give off plutonium-239 and emit a beta particle. So that's it for question A. And next up for question B, it is saying that the half-life for the decay of uranium-239 to neptunium-239 is 23.5 minutes, and calculate the percentage of the sample of uranium-239 remaining after 2 hours and 21 minutes. And the half-life for the decay of uranium-239 is 23.5 minutes, meaning that it takes 23.5 minutes for 50% of the uranium-239 to undergo radioactive decay. And so therefore first, we'll be calculating the number of half-lives that uranium-239 has gone through after 2 hours and 21 minutes. So first, I'll be converting 2 hours and 21 minutes into 141 minutes. And to calculate the half-lives, I will be getting 141 divided by 23.5 minutes to get a total of 6 half-lives. So after 2 hours and 21 minutes, uranium-239 has undergone 6 half-lives. And since the half-life is 23.5 minutes, it means that after 1 half-life, 50% of the uranium-239 remains, and therefore after 6 half-lives, I'll be taking 1 half and by the power of 6 to get 1/64, and I convert it into decimal places and times 100 to get the percentage of uranium-239 remains, which is 1.56%. So therefore, after 2 hours and 21 minutes, there is 1.56% of uranium-239 remains. So for part C, it is asking that in a breeder reaction, plutonium-239 can react with 1 neutron to form strontium-90 and barium-147 to produce energy and more neutrons. Deduce how many neutrons are produced for each atom of plutonium-239 that reacts during this process. So first of all, what I'll be doing is that I'll write out the nuclear equation. So the questions say react plutonium-239 with 1 neutron to form strontium-90 and barium-147 to produce energy and more neutrons. And since we are finding the number of neutrons, I'm leaving a little space here so that we can figure out how many neutrons do we need for this equation. And since since in a nuclear equation, the total mass number and total atomic number on each side of the equation must be the same, it means that the number of protons and number of neutrons for both sides of the equations are equal, and therefore we'll be looking at the number of protons and neutrons for each side first. So on the left side, we can see that we're having 94 protons and 146 neutrons. The number of neutrons can be calculated by getting the mass number and minus the atomic number, which is 239 minus 94 to get 146. And on the right side of the equation, we're having 94 protons, in which I'm getting 38 and plus 56 to get 94, and the number of neutrons can be calculated using the same methods as in the left side, and I get 143 neutrons. And since the number of neutrons on both sides of the equation has to be the same, I am realizing that I'm lacking 3 neutrons, and so therefore I'm adding 3 more neutrons into this nuclear equations to get a total of 3 neutrons are produced for this nuclear equation. And next up, I'll be looking at another question, which is outline how the following contaminated substance might be treated. Substance A, protective clothing used by a workman to carry out routine maintenance at a nuclear power plant. And substance B, spent fuel rods containing the remnants of plutonium-239, which has a half-life of 24,110 years. So the steps that I'll be taking in solving this question is that to first of all to classify the type of nuclear waste, because as we may remember, the classification of nuclear waste is important in determining the disposal type as well as the safety measures for each of the type of nuclear waste. And therefore, in part A, we can realize that protective clothing that have been contaminated with radioactive materials are classified as low-level nuclear waste, and therefore it will be disposed as incineration, or it can be also buried in landfill sites. And for substance B, spent fuel rods containing the waste of plutonium-239 can be classified as high-level nuclear waste, and therefore its disposal method is that unless it can be reprocessed for further use, it should be vitrified and encased in steel and concrete and then buried deep underground in an area that is geologically stable. Vitrification is basically the process of turning the waste into glass. And so if any of these questions you guys are having problems with, please review your materials again in the other video. And thank you for watching.